Alright, so this is section 2.1 in Stewart's 7th edition calculus book, the tangent and velocity problem. So, I'm going to start off by saying a couple things. First off, the secant line. The secant line is a line that intersects a graph at two different points. It's intersecting this graph in 2 points. And a tangent line is a line that intersects the graph at only a single point. And one more thing, line segments, you'll have an initial point P and a terminal point or a final point Q. And for this problem, we're given time in minutes and volume in gallons with this data set. And so it says a tank holds 1,000 gallons of water that drains from the bottom of the tank in half an hour. The values in the table show the volume V of the water remaining in the tank after T minutes. So after 30 minutes, there's no more water left in the tank. At 15 minutes, there's 250 gallons left. And of course, at 0 time, 0 minutes, the tank is full, 1,000 gallons. So there is a visual here where time is on the x-axis and volume in gallons is on the y-axis. Starting right here, time is 0, 1,000 gallons, and it's decreasing over time until it gets to 30, which is 0. So part A says if P is the point 1520, where you can look at it as an X and Y ordered pair. P is the point 1520 on the graph of volume. Find the slopes of the secant lines PQ when Q is the point on the graph of these varying time intervals. So you have your initial point P, which is this ordered pair, 15 minutes, 250 gallons. And then Q will be varying over the different times, 5 to 30, leaving out 15, and the initial time 0. So you can look at all these as XY ordered pairs too. And slope, or M, is equal to y2 minus y1 over x2 minus x1, which is also change in y over change in x. Or you could look at it as the y final coordinate minus the y initial coordinate over the x final coordinate minus the x initial coordinate. So for your first t equals 5 minutes, the line segment PQ slope will be equal to the terminal point Q y coordinate minus the initial point P y coordinate over the terminal point x coordinate minus the initial point x coordinate, which would be this ordered pair here as your Q point, and this ordered pair up here as your P point. So that gives you 694 minus 250 over 5 minus 15. You get that your slope is equal to negative 44.4. Now at t equals 10, you're doing the same thing, but instead of this ordered pair, you're using the next ordered pair, 10, 4, 4, 4. So your slope is equal to 444 minus 250 over 10 minus 15. You get that your slope is negative 38.8. At t equals 20 minutes, your slope is 111 minus 250 over 20 minus 15. You get negative 27.8. And that comes from this ordered pair that you're using for Q. And you're still using the same P coordinate because you're looking for the slope of the secant line at point P at point P, line segment PQ. And at t equals, oh, we did that one. At t equals 25, your slope is 28 minus 250, that's your gallons. 25 minus 15, that's your time. You get negative 22.2 is your slope. At t equals 30, the tank is empty. 0 minus 250 gallons over 30 minutes minus 15 minutes. You get negative 16.6 repeating is your slope. Part B is asking you to estimate the slope of the tangent line at point P by averaging the slope of two secant lines. And while you can get some pretty close answers still from using any of these secant lines, like this one or this one, the slope of the graph is changing, decreasing over time, but it's asking about estimating the tangent line at this point P right here, this point. So the most accurate estimation would be using the secant line PQ, where with the closest points to it, which would be this one at 10, 444, and the one at 20 minutes and 111 gallons. So you have these two line segments, PQ. You have the top one and the bottom one. And if you average those two, you just take your slopes from those. It was the ones closest to point P will be the most accurate estimations. So that's at t equals 10 and t equals 20. Since they're closest to point P, it'll give us the most accurate estimation of the slope of the tangent line at point P. And at t equals 10, we have slope equal to negative 38.8, and t equal 20, we have negative 27.8 is equal to m. So if you add those two slopes together and divide by 2, you get that negative 33.3 repeating is your estimation for the slope of the tangent line at point P. Now, part C is asking to use a graph to estimate the slope of the tangent line at this point. And since you're using the graph, I just rounded the numbers. This 444 gallons, I rounded that to 450 at time of 10 minutes. And I rounded the 111 gallons to 100 gallons at 20 minutes. And I evaluated as you would in part A, 450 gallons minus 250 over 10 minutes minus 15 minutes. You get negative 40 is equal to your slope. And 100 minus 250 over 20 minus 15, you get negative 30 is equal to your slope. And then averaging those two, adding them together, dividing by 2, you get negative 35 is equal to your slope estimation of the tangent line at point P.